One thing in our studies is getting to study a topic or be taught a topic. And then another important thing, as long as we take examination, is to be able to apply the knowledge of the known, that is, what we have learned, to be able to solve problems. Okay? Then when you are tried by an examiner, how can you use the knowledge of what you've learned to deal with the questions that the examiner is going to ask you? For this reason, I am welcoming you to the GMAETS 41's chemistry class today, where I'll be taking you on examination questions based on our previous class on atomic structures. So in this class, I've been able to gather questions from different exam bodies, upward of 50 questions and more, But this is what I would have us do. We're going to take these questions bit by bit. We'll consider some in this class, then subsequently in other classes we'll also solve or give answers to other questions on atomic structures. Alright, I'd like you to give attention as I dictate the question. Is that okay? And their option. Then we use the idea of our previous class, as the case may be, to see how we can analyze the question so as to hold the examiner to a standstill. Let them not dribble you, Alright, so you pay attention. You may decide, as the case is, to pen them down as I dictate this question. So very well. So our first question we have here, right? An element X has 127 neutrons and 82 electrons. Its atomic number is A, 209, B, 105, C, 45, D, 82. I'm going to read it again. An element X has 127 neutrons and 82 electrons. Its atomic number is A, 209, that is 209, B, 105, that is 105, C, 45, that is 45, D, 82, that is 82. Now, how do we answer this question? It's a simple one. Now we're given the number of neutrons to be 127. It's important to state that with respect to this question, we are looking for the atomic number. Now the atomic number, on the normal as it is, has nothing to do with the neutron number. Are you following? Since the mass number was not given to us. If mass number was given to us, we can do mass number minus neutron number to get atomic number, which is also the same as proton number. But in this case, we're only given the neutron number 127 and the number of electrons to be 82. So we don't have any business with this neutron number in this question. We are going to apply the knowledge that for an atom that is electrically neutral, that is, the atom has not reacted. Are you getting me right? The number of electrons is equal to the number of protons. Remember, number of electrons. Let me use E negative, is equal to the number of protons. Permit me to use P positive, From our previous class, we learned that electrons are negatively charged, while protons are what? Positively charged. So if an atom has not reacted, which in this question, we were not told that this atom reacted. Atom X, we were not told that it reacted. Therefore, we will assume that it didn't react. Is that clear? And for that reason, the atom is considered to be electrically neutral. And we can conclude that the number of electrons is equal to the number of protons. On the basis of that, the number of protons here, according to the question, we have 82 protons. Good. 82 protons. How do we now conclude to determine what the atomic number of element X is going to be? This is where we set out the condition that for an electrically neutral atom, the number of electrons is also equal to the atomic number. The number of electrons is also equal to what? The atomic number. So in conclusion, we are saying that as long as an atom has not reacted, the number of electrons is equal to the number of protons, and that is equal to the atomic number. Now let me say this as a summary of this, right? Atomic number is always equal to proton number, whether the atom has reacted or not. If an atom reacts, you get a ion. So whether it is an ion or an atom, the proton number is equal to the atomic number. So we can conclude, therefore, that the atomic number of X in this case equals 82. That's the correct answer. And from the we have here, option A is 209, option B is 105, option C is 45, option D is 82. So the correct answer to this question is 82. I hope it makes sense, right? If you've got any question, remember, you can always ask your question. Just drop your question in the comment section and I will be there to respond to your question. We shall be moving on to the next question. The next question here, the mass of an atom is determined by, the mass of an atom is determined by A, its ionization potential, B, its electrochemical potential, C, the number of protons, D, the number of neutrons and protons. Once again, the question reads, the mass of an atom is determined by A, its ionization potential, B, its electrochemical potential, C, the number of protons, D, the number of neutrons and protons. Of course, from our previous class, might do well to take the lesson from our previous class. Is that okay? On atomic structure. I explained that to get the mass number, simply the mass of an atom, we need the atomic particles in the nucleus of the atom. The atomic particles in the nucleus of an atom are the protons and the neutrons. So the protons and neutrons, they make up the nucleus of an atom. And it is in the nucleus of an atom that the mass, the weight of that atom is concentrated. Therefore, for us to get the mass of an atom, the mass number of an atom, the atomic mass of an atom, the weight of an atom, all we have to do is to add the number of protons to the number of what? Neutrons. So, coming to this question, we conclude that the mass of an atom is determined by the number of neutrons and the number of protons, which is option D. So I'd like to write, this is our first question. Question 2, I would like to write that the mass of an atom, mass, if you want to simply use mass, or you can say mass number, or you can still say atomic mass, or we can also use the term atomic weight of an atom is equal to the number of neutrons. Permit me to use n, small letter n for number of neutrons. N has no charge, so I leave it that way, then plus p. That p is positive, so permit me to use n plus p. So what we've established here is that if you want to get the mass number, the mass of any atom, all you are expected to do is just to add the number of neutrons to the number of what? Protons. So that is it. We are moving, so you can see how we are using our previous class knowledge, okay, to attack these questions here as the examiner requires of us. Now the next question I have here is, Okay, we've answered the second question. So the next one I have, number 3, a particle that contains 9 protons. A particle that contains 9 protons, 10 neutrons, and 10 electrons is a particle that contains 9 protons, 10 neutrons, and 10 electrons is A. Positive ion. B. Neutral ion of a metal. Neutral ion of a metal. C. Neutral atom of a non-metal. Neutral atom of a non-metal. And then D. Negative ion. D. Negative ion. Once again, let me read the question so that you follow through the analysis. A particle that contains 9 protons. Take note, how many protons? 9. 10 neutrons. How many neutrons? 10. And 10 electrons. What will that atom be? Will the atom be, according to A, positive ion, B, neutral atom of a metal, C, neutral atom of a non-metal, D, a negative ion? What do we say? How do we answer this question? It's a simple one. Let's do the analysis together. This is our question number 3. In the question, we're given the number of protons, the number of neutrons, and the number of electrons. Number of protons, P plus, okay, is equal to 10 from the question. And of course, the number of 10 from the question was given to be 10. Oh no, come back. Number of protons is 9 as given. Number of protons, electrons is, number of neutrons is 10, and the number of electrons is 10. Number of electrons is 10. Good. Now, there is something very important you would want to take note about this question, all right? That the number of protons and the number of neutrons, they are not equal. They are different. They are different. And what does that tell us? When the number of protons and number of electrons are not equal, when they are different, it simply means that that atom has reacted. That atom has done what? Reacted. In our previous class, you remember that I also defined a ion. And we said that ions are obtained when atoms react, either by losing electrons or what? Gaining electrons. So this is the idea. If the atom has not reacted, I said that, I guess, in question number 1. When an atom hasn't reacted, the number of protons and the number of electrons are expected to be the same. They're expected to be what? The same. I repeat, when an atom has not reacted, the number of protons and the number of electrons are expected to be the same. And what determines it, the main number that will determine what that atom is the proton number. So in this case, for this question, the atom that we are dealing with here is an atom that the number of protons is 9. If this atom has not reacted, it will be expected that the number of electrons will also be what? 9. But unfortunately, observe that the number of electrons here is not the same as the number of what? Proton. Which simply means that this atom has what? Reacted. Therefore, this question, the atom here is actually an ion. It's actually what? An ion. The question will now be that this ion, is it a positive ion or a negative ion? To answer that question, it depends on whether the atom gained electrons or lost electrons. Are you following, right? If an atom gained electron, that will give you a negative ion. It will give you a negative ion when it gains an electron. And when an atom loses an electron, it will become a positive ion. Now, if you look at this, how will we determine whether this atom gained or lost electron? Are you following, right? That would depend on the number of protons here. How many protons we have here? 9. If this atom has not reacted, then we expect the electron to also be what? 9. But if you take note of this, you notice proton is 9 and electron is what? 10. So the electron increased, which simply shows that this atom gained an electron. How many electrons? 1, because the number of proton is 9, the number of electron is 10. So this atom here gained 1 electron. And remember what we said, when an atom gains an electron, it becomes a negative ion. We actually call the negative ion anion. We call it what? Anion. So it is negative ion of a non-metal. Let's now go back to the options and see. I've analyzed this question so that while I choose the correct option, you will actually agree with me. So a particle contains 9 protons, 10 neutrons, and 10 electrons. Alright? Now, that particle, what is it? A, positive ion. It's not positive ion. It's not positive ion because it gained electrons. B, neutral atom of a metal. It is not a neutral atom because the number of protons and electrons here are not equal. C, neutral atom of a non-metal. Once again, it is not a neutral atom. Yes, we agree this is a non-metal. I've explained that because it gained electron. Non-metals gain electrons, while metals, they lose electrons. I think I talked about that in our previous class. So this is not a neutral atom. Is that okay? So option C is not the answer. Then option D said that it is a negative ion. Of course, that is what I'm going for. The correct answer here to question number 3 is negative ion. Therefore, the particle is negative ion. And that, of course, is option D. We'll be moving on to our next question. However, I hope you understand what we've done so far. Always remember, you can make use of the comment section, like I said, ask your question if you do have. And if you are yet to subscribe to the GMAETS 41's channel, what is holding you back? Just click on that subscription button, turn on the notification bell. You know why? So that anytime I upload any new content or whenever I'm live like this, where you can engage with me, you'll be personally notified. If you do not turn on the notification bell and personalize your notification and subscription, if you don't personalize it, whenever I update a new content, all right, you will not get the notification. So please hit the subscription button, turn on the notification bell, personalize the subscription, all right, so that once I upload any content, you will be personally notified. And don't forget, please, all right, I'm appealing to you, begging, can become channel members in order to support the growth of this channel so that we'll continue to give you the best. Below this video lesson, you have the subscription, the join button rather, okay? Just click on that join button. The packages will appear available on GMAETS 41. Whichever is convenient for you, please do feel free to select that package and support us. We really appreciate. All right, let us move on to our next question. An electron can be added to a halogen atom to form a halide ion. I'll take that again. An electron can be added to a halogen atom to form a halide ion with A, 8 electrons, B, 7 valence electrons, C, 2 valence electrons, D, valence electrons. I'll take the question once again. An electron can be added to a halogen atom to form a halide ion with. So we are saying when you add electron to a halogen, you expect to get a halide ion. Yeah, group 7 elements, they are called halogens. When they react, we call them halides. So when you add electron to a halogen, it's going to form a halide ion. That we know. Now, how many electrons will it have? Perhaps in the outermost shell. That is what this question is based on. Option A said valence electrons of 8. That is 8 valence electrons. B, 7 valence electrons. C, 2 valence electrons. D, valence electrons. The correct answer here is option A, which is 8 valence electrons. How do we know that option A is the correct answer? Question number 4. All we have to do is think about the outermost shell, the valence shell of halogens. Halogens are group 7 element. All right, so under periodic table, I'm going to teach you that. Are you following, right? But for now, it doesn't matter. We have a question from atomic structure that can be applied to this idea of, periodic table, knowing what a halogen is. Am I communicating? So a halogen, they have 7 electrons in the outermost shell. They have what? 7 electrons in the outermost shell. So if you have anything drawn like this, and the outermost shell you have, let's say 1, 2, 3, 4, 5, 6, and 7. This is a halogen. It is a halogen, outermost shell. Are you getting me right? Now, if it gains 1 electron, let's say plus 1 electron, what we expect to get? The structure will now look like this: 1, 2, 3, 4, 5, 6, and 7. This is the halogen initially. Gaining 1 electron, the electron will be attached here. Let me use cross for the electron. Is that okay? That it gained. So how many electrons altogether? It becomes 8. And so that outermost shell is complete. This is halide ion. With how many electrons? 8 electrons. You can find out yourself. So the number of valence electrons, number of electrons in the outermost shell, when a halogen gains 1 electron to form halide ion, the number of valence electrons is 8. All right, I want to believe we are learning. Does this answers make sense to you? Remember, like I said, these are based on our previous class on atomic structure. If you've not taken that lesson, please kindly check through our channel under live. You will see that video lesson, okay? Or you can go through our chemistry playlist, GMAETS 41's chemistry playlist, and you would see that video lesson. Either the chemistry playlist for JAM, WAEC, and O-level students, SS1, 2, and 3, or the chemistry playlist for advanced level, ICH 111, that's what you start with, okay? And you can go there also and check. You will see the video lesson on structure. But to easily locate, you just go under the live, tap live, and you will see the video lesson on atomic structure. Remember what we're saying. One thing is to be taught a topic or to study a topic. Another thing is to apply knowledge of the known to your exam questions as examiner may demand of you. We'll be moving on to the next question. Right, Videx, you asked what question, what subject, please? We are dealing with chemistry, is that okay? We are dealing with chemistry. Kevo, you're welcome. You're welcome. All right, so let's take the next question here. The next question, we have this. The component of an atom that contributes least to its mass. I'll take the question again. The component of an atom that contributes least to its mass is A, nucleus, B, neutron, C, electron, D, proton. I'm going to take the question again. The component of an atom that contributes least, which means, well, it may contribute, but the contribution is very minimal. But of course, sometimes you can just neglect it. right? Okay, the component of an atom that contributes least to its mass is the A, nucleus, B, neutron, C, electron, D, proton. The mass of an atom, what determines it? In our previous class, I taught you about atomic particles, the fundamental particles of an atom. You recall that I mentioned there are 3 fundamental particles of an atom. By the way, please, let me also say this. In that previous class, I told you that we have other atomic particles, but we don't regard them as fundamental. Okay, like the one we call positron, neutrinos, quarks. These are subatomic particles. Now, coming back to the fundamental particles of an atom. There are 3 of them, I told you in our previous class. 1 is the proton, 2 the neutron, 3 the what? Electron. And I explained that the mass of the atom is concentrated where? In the nucleus of an atom. Now in that nucleus, you have the protons and the what? Electrons. These 2 particles are responsible. They determine the mass of an electron. Oh no, the mass of an atom rather. The protons and the neutrons are responsible. They determine the mass of an atom. Electrons are not seen. They are not found in the nucleus. They are found in the surrounding, which is another region of an atom. Now, they do not contribute much to the mass, to the weight of an atom. They do not contribute much to it. I repeat, the electrons do not contribute much. And what is the reason? They are not in the nucleus of an atom. They are not there. The mass of an atom depends on the atomic particles in the nucleus. Therefore, in answering this question, the particular atomic particle that contributes least to the mass of an atom is the electrons. And remember, I told you the reason, because they are not found in the nucleus. Rather, electrons are found in the surrounding. The correct option here, I think, where is our electrons? Let's see. Good. Option C. Option C. Electrons contribute least. They contribute least to the mass of an atom. Don't forget the reason, because an examiner can also decide to ask you a question based on the reason. Am I communicating right? Yeah. What if I ask you, an electron contributes least to the mass of an atom because it could have options given to you? And what did I say is the reason? They are not found in the nucleus of an atom.